Hello! Okay, what we're going to do today is a little fraction review, and we're going to start out with multiplying of fractions. So we've got this first fraction here, 1/2 times 3/5. And one of the things I always say about multiplying fractions, we really like it because it's very straightforward. You're just going straight across. So all we're going to do here is we're going to multiply the numerators, 1 times 3, and the denominator, 2 times 5. And so what do we get? 1 times 3 is 3, and 2 times 5 is 10. And we end up with our answer, 3/10. Okay? Very straightforward. That's why I always start with multiplying fractions, because it's just straightforward right across. Now, I've given us a second example, 5/3 times 9/2. And I want to show you that if we multiply straight across, which we can totally do, and we should, what we're going to get is 5 times 9 is 45. And 3 times 2 is 6. So notice we just multiplied straight across again. We got 45 over 6. Now, we have two issues with this. First, that's an improper fraction. It's top-heavy, meaning the top number, the numerator, is larger than the bottom number, the denominator. The second issue is it can be reduced. If you remember reducing, we'll talk about that in just another moment. But let's go ahead and make this back into a mixed number. So how many times does 6 go into 45? So we go over to the side here. We're going to go ahead and solve for 45 divided by 6. So how many times does 45 go into 6? Well, 45 divided by 6, let's see. I know 6 times 8 is 48, and 6 times 7 is 42. So it goes in at least 7, but 8 was too many. So 6 times 7 is 42. We go ahead and subtract there. We get 3. And now, at this point, there's 3 different ways that we've learned to deal with this. Back in elementary school, we would have come up here and said, remainder 3. Okay? Then, somewhere around, 6th grade, middle school, something like that, you learned about adding on a decimal 0. So you could bring that down. Well, oops. If you do, the decimal goes up there. And now, how many times does 6 go into 30? Right, 5 times. So 5 times 6 is 30. We do our subtraction again, and we have our 0 remainder. So 7.5. But later still, probably in Algebra 1 last year, maybe a little sooner than that, we learned one more way to deal with this. And this is what we're going to need to know here. The other way we learned to deal with, instead of a remainder or adding a decimal 0, is to take this remainder and put it on top of the divisor. So we get 7 and 3/6. And now we have to reduce the 3/6. So how many times, what's a common number that goes into 3 and 6? Right, 3 goes into both of them. Not 2. 2 doesn't go into 3 nicely. But 3 will go into itself. Let's change that color, make that blue. There we go. So divide by 3, and we end up with our final answer of the whole number 7. 3 goes into 3 once, and 6 divided by 3 is twice, 7.5. Notice our decimal answer was 7.5, which is the same thing. Now, I had mentioned we could have done cross-reducing earlier, not cross-multiplying. That's for proportions. We'll talk about that later. But cross-reducing is when looking across and multiplying, you actually can reduce some of these values. They have a common number that divides into both diagonally. So, is there something that goes into 2 and 5? No, not nicely at least. A decimal, but not nicely. But 3 and 9? Yeah, 3 goes into both of those. 3 goes into 3 once. 3 goes into 9 3 times. And if we now multiply, we get 3 times 5, which is 15, and 2 times 1, which is 2. Notice these numbers down here are a lot smaller than these numbers right here. So this is a little easier to deal with. Right now, we could do the division probably in our head. How many times does 2 go into 15? Right, 7 times. And how much is left over? 7 times 2 is 14. So there would be 1 left over. And the denominator remains the same. Look, we got the same answer of 7 1/2. Same as over here. So now let's go to this last example, which is where we have mixed numbers multiplying with fractions. And we can't just start multiplying yet. We have to change the numbers like here to improper fractions, where it's top heavy. And who remembers how to do that? Well, so the first thing we do is we want to take this whole number, and the shortcut way to think of it is just take this whole number times the denominator, 1 times 3 is 3, and add it to the numerator. So I kind of look at it like this, times and add. And what you're really doing, if we do this, 1 times 3 is 3, plus 1 is 4. Denominator stays the same, 4/3. And what is that? Well, what we did when we did 1 times 3 is we found the whole number equivalent of what 1 is in the fraction of thirds. So 1 is the same as 3/3. And when we added 3/3 to the 1 here, the 1/3, that gave us 4/3. We do the same here with the 2 and 2/5. So we're going to multiply and add. 2 times 5 is 10, plus 2 is 12. So times 12/5. Now, if we multiply straight across, we get some pretty big numbers, 48 and 15. I'm going to go for smaller numbers. So let's do some cross reducing. Is there a number that goes into 3 and 12? Yeah, 3, right? 3 goes into 3 once, 3 goes into 12 4 times, right? How about 4 and 5? That diagonal. Yeah, no, it doesn't work, does it? Okay, so now we're going to multiply straight across, and we're going to come up with the final answer. 4 times 4 is 16 over 5 times 1. Well, that's not quite the right answer yet, is it? Because it's improper. We need to change it to a mixed number. The only time we'd really leave it as improper is if we were working with slope. And we'll do some of that later this year. Because with slope, you want to think of rise over run. And there's no whole number in front of that. So that's the time you would leave it as a improper fraction. But for now, we're going to go ahead and reduce this. Let's see, how many times does 5 go into 16? We can do this one. Yeah, we'll see. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. And 5 times 4 would be 20. That's too much. So 5 will go into 16 3 whole times. 3 times 5 is 15 with 1 left over. So 15 minus from the 16, right, leaves you 1 left over. The denominator remains the same. So we actually end up with 3 and 1/5. And there you go. There's your multiply with fractions review, folks. Next, we're going to do division, and I'm going to give you a reason as to why we're doing this. There is a reason I'm reviewing fractions in all my classes, and it's pretty important for your next class, for the next thing, and for building on these things. So we'll talk about that next video. See you then.